Well, hey there, kiddos. Here is your video for number 6 on your review, and then I am also putting the step-by-step directions for what I did for 10 through 14 on here as well, so you can see how I used the calculator, because that's how I did all those questions. Number 6, like I told you, there is a question like this on the test tomorrow that's a bonus question, so hopefully this will help you. If it doesn't, it is just a bonus. It's not the end of the world. So you have a picture here, and it tells you that Julie wants to expand her 24 by 16 foot garden by planting a uniform border of flowers. Uniform means it's the same all the way around. So the next sentence is redundant. It says the border will be of the same width around the entire garden. That's what uniform means. So the flowers she bought will fill an area of 276 feet squared. We want to know how wide the border has to be. Well, this is just like when you were in 7th and 8th grade and you had to find the area of something and you had to find the area of the shaded region. This is nothing more than a shaded region area problem. I want to find the area of this shaded portion of this rectangle, which means I've got to find the area of the whole thing and subtract the area of what's on the inside, and that will give me the length, how wide this border is going to be. So I'm going to have to do the area of the whole thing. So I have to do length times width. So I'm going to do 24 plus 2x times 16 plus 2x. And I have to subtract from that the area of this inside piece. So I have to subtract 24 times 16 from that. And that has to equal 276 because that's what it tells me the area is going to be. So I'm going to multiply these together using my double distributive property. And I've already done this with my calculator, so I happen to know what the numbers are. You can double check me if you want. But 24 times 16 comes out to be 384. 24 times 2x is 48x. 2x times 16 is 32x. And then 2x times 2x is going to be 4x squared. And then 24 times 16, I already did over here, is 384. And this all equals 276. Well, this 384 and this 384 will cancel because they have opposite signs. 384, negative 384. So just have to deal with what's right here. Well, I can combine these two terms because they are like terms. So 48x plus 32x makes 80x. And I'm going to write this in standard form. So I'm going to put the x squared term first. So I'm going to do 4x squared plus 80x. And that equals 276. But before I can do anything with this, I'm going to have to make it equal 0. So I'm going to subtract this 276 from both sides. And now in order to solve this and find out what x is, I'm going to have to factor this. But this is heinous. I've got a coefficient in front of the x squared. This number is gigantic. So the first thing that I did, and I was like, maybe all of these numbers are divisible by 4. And so I checked that first, because if they're all divisible by 4, I can pull a 4 out and it makes this easier to factor. So I checked it. They're all divisible by 4. So I'm going to factor out a 4. And when I take a 4 out of all of this, this becomes x squared, this becomes 20x, and this becomes 69. I just went and divided all of these by 4. Now, so that I can factor and find out what x equals, I'm going to get rid of this 4 out here by dividing both sides of my new equation by 4. So I just end up with this x squared plus 20x minus 69 equals 0. So if I factor this, I should be able to use those factors to find the positive root, and that positive root will give me the width of the border, which is what I'm looking for. Now, I don't know about you guys, but negative 69 here is kind of a large number, and in order to come up with two numbers that multiply to negative 69 that add to positive 20, I'm going to have to start listing factors. Well, that's going to take a little bit, and I don't really want to start listing factors. So what I did is I'm going to use my calculator, and I'm going to show you something that will help you if you are stuck trying to find factors of something that work, because sometimes that's a problem. If you'll go to y equals, and I want to find factors of 69, then I'm going to do, let me clear out the 0, 1 second. In my y1 here, I'm going to put 69 because that's the number I want factors of, divided by x. And what this will do is when I go look at my table on my calculator, it's going to list all the factors of 69. So if I do second and graph, and it lists all the factors, it will not, even decimal, they're not just whole number factors, but you see 1 times 69 makes 69. 2 times 34.5, if you don't believe me, that makes 69 when you multiply. The next one is 3 and 23. I only want to look at the whole number factors. I don't care about these that have decimals. I just want to look at whole numbers. And remember, I'm dealing with a negative 69, which means one of these numbers has to be negative. And then I have to have a positive 20. So when I add them together or subtract the two numbers, it's got to equal 20. So I'm going to go back over here. If I do 1 times 69, obviously that makes 69. But if I do 69 minus 1, that makes 68. That's not the number I want. I want a 20. So let's do the next set of whole number factors. It's 3 and 23. If you multiply that, it makes 69. And if I do 23 minus 3, there's my 20. So here are your two factors, but one of them is negative. It's negative 3 and positive 23. And your calculator won't do that part for you. If you put the negative 69 in, it just makes all of the y values negative, and that's not always going to be how it works. So you'll have to guess and check and use some logic to figure out which one's negative. But there they are. So I know that my two factors are going to be x minus 3 and x plus 23. Because when I multiply those two numbers, I get negative 69. When I add these two numbers, I get positive 20. So I have two factors. So to figure out what x is, so I can find the border, I'm going to set them equal to 0, and I'm going to solve both of them for x. And since we're dealing with the width of something, I only want the positive root. So if I add 3 to both sides for this one, I get that x equals 3, and that's a positive root. So that's probably going to be my answer. So over here, if I subtract 23 from both sides, I get x equals negative 23. And since the width of something cannot be negative, this is my distance. So the width of this border from here to here is 3 feet. So there is that question. If you still have questions over that, what I did, why I did what, I'll be at school about 8:15 in the morning. You can come ask. So now let's look at 10 through 14. I posted the answers, the solutions are up on the website, but I didn't show any work for this because all I did was use my calculator and got the answers based on what I saw on my calculator. So I know that an object is hurled upward from the ground with an initial velocity of 108 feet per second. The height in feet of the object at any given time t in seconds is h of t equals negative 16t squared plus 108t. So I took this equation and I put it in my calculator. So over here I went to y equals, and I typed in that equation. So I have negative 16 x squared plus 108. I missed the 1. 108 x. And in order to answer these questions, when will it reach a height of 100? When will the object hit the ground? When does it reach its maximum height? All of that I can get by looking at the graph. So I pressed graph, and it's set on a standard window right now. And if you will notice, I can see everything except for the top of my graph up here. I don't know where the vertex is. So I'm going to have to adjust my window. And in order to adjust my window, I'm going to go to second graph, and I'm going to look at my table. I need to know about where this is going to hit its maximum height. And so I'm going to look at the y values, and I'm going to see what the biggest one is I can see. So, and I'm only looking at positive numbers. So everything between here and here, negatives I don't care about. I'm looking for a maximum, not a minimum. My biggest number that I see here is 180. So I'm going to go set my window so that my y max value is going to be a little more than 180, so I can make sure I see my entire graph. So I'm going to make it 200. And I'm going to change my scale. Since I'm going from negative 10 to 200, I'm going to have it count by 20s. Now I'm going to graph it again. And so here is my parabola. So now you can see exactly what's going on, and I'm going to use this and some calculating functions on my calculator to figure out the answers to my problem. So the first question says, when will it reach a height of 100 feet? Well, that means that in y equals over here, my second equation, I'm going to put in a 100 because I want to know when it gets to 100. Try that again, 100. And I'm going to graph it, and it's going to draw a line at 100 for me. And it reaches 100 feet twice. So I'm going to have to find this intersection point and this intersection point. So to do that on my calculator, I'm going to press second, trace, and I'm going to choose option 5, intersect. And so for the first time, it's going to ask me some questions down here. First curve, second curve. So all I'm going to do is I'm going to go enter, enter, until it says guess. Because now it's just asking me, telling me, where do you want me to look? So the first time I do this, I want it to look right here at this root. So I'm going to hit my arrow until my cursor gets over here close to that root. That's good. And I'm going to hit enter again. And it's going to tell me that my intersection is at negative 1.1, blah, 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 and y equals 100. Well, I know y equals 100. That's what I told it to equal. This is what I'm interested in. X is your number of seconds, Y is your distance. So I need this to be in seconds. So I'm going to call this about 1.1 seconds, which is what it said on my answer key. So the first time it hits 100 feet is 1.1 seconds. Then to find the other one, I need to know this intersection point. I do this again. So I'm going to go second, trace. I want the intersect again. Again, I'm going to go enter, enter. And then I'm going to hit my arrow key, and I'm going to move my cursor over until it gets close to that one over there on the right. And then I'm going to hit enter again. And now you see that this one comes out to about 5.6. So that's how I got those two numbers. So it's going to reach 100 feet at 1.1 seconds and at 5.6 seconds. Now to find out when it reaches the ground, that means that my distance is 0. So I go back here to my y equals, and that means that I want this second equation to be 0 because that's now where I want to look. And so I'll hit graph and have it draw that in for me. And as you know, that y equals 0 is just going to be on the x-axis. That's all we're looking for. This isn't a nice, pretty whole number. So I'm going to have it actually find it. I don't care about this 0 because this is where it started. What I'm interested in is when did it hit the ground. It hit the ground over here. So again, we're going to do second trace and find the intersection. And we're going to go enter, enter. And then we're going to move our cursor over to this one to the right, because that's where we want it to look. I know what the one on the left is. It's 0, 0. This one over here, though, is not. I'll get it over there close and then hit enter. And you're going to see that the intersection is right at 6.75. So to hit the ground, it took 6.75 seconds. Now 12 and 13 go together. They say, when will the object reach the maximum height? So this is time. What is the maximum height? This is distance. So this one is looking for the x value. This one's looking for the y value of the maximum or the vertex. So if you look at your calculator, I want to find this point up here. I need to know what the maximum is. So I'm not going to change anything in my y equals. I'm just going to go to second, trace. And this time I'm going to choose maximum because that's what I want. So I'm going to hit number 4. And it's asking me some questions. It says left bound, which means please mark the left side of the vertex. So my cursor is way down here. I'm going to have to move my left arrow until I get it over here to the left of my vertex. So I'm going to hit my left arrow until I get it over there. And just as long as it's to the left of the vertex, it doesn't have to be very far left, just left. So that's on the left side of my vertex. I'm going to hit enter. You see it's going to mark it with the arrow. Then to find the right bound, I'm going to move it now to the right side of where the vertex is. And I'm going to hit enter. So it will now mark it with an arrow. So these little lines say, look here, this is where you should see. Now to make a guess, put your cursor where you think the vertex is and then hit enter. And it's going to tell you that the maximum is here and here. X is your time, Y is your distance. So I'm going to call this 3.4 seconds. So it's going to reach its maximum height at 3.4 seconds. And the maximum height is 182.25. 182.25, and my units are in feet. Now, number 14 just asks for the domain and range of the graph. Well, domain is all of the x values, and like I told you when we're looking at this graph, the x values down here are your time. And we've already established what this x value is and what this x value is. This one's 0, and this one we found a minute ago over here in one of our questions, it was 6.75. So I know that my domain of my graph, this situation that's happening, goes from 0 to this number because this is where it hits the ground. So my domain is just all of the x values between 0 and 6.75. And that's where I came up with those numbers. Where it hit the ground is where it ends. And so that's the end point of my domain. The 0 is where it started. My range is the y values. And we established a minute ago that the y is the distance this object travels. Well, it started at 0. We don't care about all of this stuff in the negative. We're talking about an object being thrown up in the air. It had to start at 0. It was not thrown from underground. We're going to assume it was thrown from ground level. So it starts at 0 and goes all the way up to here. And we found that maximum height was 182.25. So my range goes from 0 to 182.25. And that's how I came up with those numbers. This was my domain. This was my range. So that's how I did that. I just used my calculator to work through them. You will be able to do that when you take your test as well tomorrow. Happy studying, and I will see you all tomorrow.